The periodic table was first put together by Dmitry Mendeleev in 1869 and Lothar Meyer in 1870. Mendeleev put his periodic table together by listing the elements in order of increasing mass, then grouping elements with similar properties and reactivities into columns. The genius thing that Mendeleev did was to leave space for elements that had not been discovered yet. He predicted that there were elements with certain masses and reactivities that were at that point unknown. Mendeleev's periodic table had a slight problem in that potassium has a slightly lower average atomic mass than argon, but should come after it on the periodic table based on reactivities. Modern periodic tables have the elements arranged in order of increasing atomic number, that is, number of protons, rather than based on mass. That fixed the problem with potassium and argon. Potassium has more protons than argon, but based on isotopic abundances, it ends up with a lower average atomic mass. The atomic number increases on the periodic table as you go left to right and top to bottom, just like reading a book. The columns on the periodic table are called groups, and they separate the elements by reactivities and properties. The rows on the periodic table are called periods. There are two different numbering systems for the groups in the periodic table. One is the official IUPAC numbering system, which just numbers the columns 1 through 18 from left to right on the periodic table. The benefit of this numbering system is that it is straightforward and easy to remember. Using this numbering system, groups 1, 2, and 13 through 18 are called the main group elements. Groups 3 through 12 and the lanthanides and actinides could broadly be grouped into the category of transition metals. The lanthanides and actinides are not actually separate in the same way that Alaska is separated from mainland United States. In actuality, these are part of the bottom two rows of the transition metals. They are just depicted separately to save space on posters and slides. They also have some slightly different properties that make them unique compared to the other transition metals. The other numbering system is actually the one that I prefer and will generally use in this class. It calls the main group elements the A's and the transition metals the B's. In this numbering system, the main group element columns are numbered 1 through 8, with 1A and 2A being on the left of the transition metals, and 3A through 8A being on the right of the transition metals. This numbering system has the advantage that the group number corresponds to the number of valence electrons in an atom. We will talk more about this later in the class. I am not making you know the numbering for the B's because it's pretty weird. It starts at 3 and then gets back to 1 and 2 on the right-hand side. Group 8B is 3 columns wide, which is also pretty weird. In addition to knowing the numbering systems, you should know the historically based names that chemists use for some of the columns. Group 1A is alkali metals, and Group 2A is alkaline earth metals. Those names are similar, so try not to get them confused. Groups 3A and 4A don't really have special names. We might name them based on their first element, so 3A might be called the boron group, and 4A might be called the carbon group. Group 5A is called pnictogens. The P is silent. To me, pnictogen sounds a lot like nitrogen, which is the first element in that group. The term pnictogen actually refers to the choking nature of nitrogen gas. Group 6A is the chalcogens. The first element in the chalcogens is oxygen, which is a major component of chalk. However, the name chalcogen is probably best translated as ore forming rather than chalk forming. Group 7A is the halogens. Halogen means salt producing. You may be familiar with some of the elements in Group 7A in halogen light bulbs. Group 8A is the noble gases. In chemistry, noble means unreactive, so these gases are not very reactive. Many of them can be found in lights, such as neon lights. The periodic table can also be divided into metals, nonmetals, and metalloids. The metals are in the lower left corner of the periodic table. Notice that the majority of the elements are metals. The top right corner of the periodic table, plus hydrogen, are the nonmetals. The metalloids basically form a diagonal line, or what we like to call a stair step, on the right side of the periodic table. If you think of groups 3A through 8A as a square, the metalloids cut diagonally through the square from the top left to the bottom right. Notice aluminum does not count as a metalloid. Below the stair step are metals, and above the stair step are nonmetals. We can compare and contrast the properties of metals and nonmetals so that if we know where an element is on the periodic table, we can predict some of its properties. Metals are able to conduct both heat and electricity well. You can think of copper wiring as a good example. Metals are malleable, that is, able to be molded into different shapes. They are ductile, which means you can pull them without them breaking easily. They are shiny or lustrous. Most metals are solids at room temperature, with mercury being one notable exception. Nonmetals are not good at conducting heat or electricity. They have a lot of different colors, whereas most metals are silvery. Some nonmetals are solids, some are liquids, and some are gases at room temperature.